Now let's see the tolerances of location, symmetry, position, and concentricity. They're defined as an area where the center axis or center plane of a feature of size is allowed to vary from the true position. The true position is established by basic dimensions. Let's see first symmetry. The tolerance zone defined by two planes equally separated from the datum plane, within which the midpoints of each opposing element must fall. It is very expensive to manufacture and inspect. Use position tolerance instead if possible. We can see the symmetry tolerance indicated of 0.02 to datum B. Datum B is a center plane formed by the feature of 1.70, which is this. From that datum, two parallel planes separated away 0.01, that is, 0.02 between them. Each midpoint derived from the internal feature of size must lie within these two planes. That is, these two opposite points we find the midpoint here. And from these, and these, and so on. All these midpoints must be within the tolerance zone. Here we can see two examples. On the left side, we can see that although the internal feature does not have a constant size, this varies symmetrically. Unlike the right side, in which the distance between the inner faces is constant, but both are skewed upwards, so this feature does not comply with the tolerance of symmetry. The inspection of the symmetry is done with two opposed indicators, which perform simultaneous measurements relative to the reference datum. The difference in indicator readings is divided between two to get the symmetry error. Concentricity is the condition where the median points of all diametrically opposed elements of a figure of revolution are congruent with the axis. It is very expensive to manufacture and inspect. Use position in place if possible. As in symmetry, here two opposite points are inspected, in this case diametrically opposed. That is, in these two diametrically opposite points, the midpoint is. Then this, and so on all around and along the feature. All midpoints derivatives must fall within the tolerance zone. In this case, is a cylinder. The concentricity inspection is done by two indicators placed on opposite sides. Then the feature is rotated 360. Variations in the indicators are observed to find the midpoints and see if they are within tolerance. As it can be seen, it is extremely complex, the inspection of both concentricity and symmetry, so it is recommended to minimize the use of these tolerances.